Hey there guys, this is Mr. Herbst here, and today our focus is going to be on this concept called acceleration. Now chances are pretty good you might have heard of the word acceleration before, and you might even know a little bit about it, what it means. But the majority of us don't really know how to use acceleration mathematically, or how to calculate acceleration, or even what sort of variables play into acceleration, and that's where we're going to get into this video. Now, before I go any further, I want you guys to take a couple seconds to check out the following video clip. Now, I don't know about you guys, but rolling down a hill in a giant hamster ball seems outrageously fun. But did you pay close attention to the speed of that hamster ball? More specifically, did you notice how it started out really slow at the top of the hill and eventually gained speed as it went down the hill and reached the top speed and then it rolled off? If you didn't catch it, watch the video clip one more time and pay close attention to the speed or the velocity of that hamster ball rolling down the hill. Okay, so hopefully you caught it this time. If not, rewind and watch that part again. But did you notice how as that hamster ball rolled down the hill, it actually gained speed? So acceleration is actually what we call a change in your velocity or speed. Now I can almost guarantee that you have felt acceleration at least one time in your life. If you've ever been in a car, in your parents' car, you'll know that when they're sitting at rest at a stoplight or a stop sign, nothing's really going on. But the second that you hit or their parents hit that gas, what happens to you? Woo, you get sucked into the back of your seat. You feel that acceleration. You feel the power of the car. And then, also, even more importantly, what you need to understand is that when you slam on those brakes, what happens to you? You feel it going forward. You are what's called decelerating. Remember, let's take a look at our equation for acceleration again. Acceleration is simply a change in speed. That change can happen if you're either accelerating, going forward, or you're decelerating and you're stopping. All right, here, guys, now it's time to get into the nitty-gritty. This here is a graph. This is an acceleration graph. If you take a look, we have velocity over here on the y-axis and time over here on the x-axis. We have velocity over time. Let's look at our definition for acceleration once again. Acceleration is a change in velocity over time. Making a little bit of sense? If not, rewatch that part again. Now, when we first look at a graph, we tend to look at what's going on at zero. Now, if you take a look at this graph, at zero, there are two lines coming off of it. One shoots up and the other one sort of caps off. Now, if you take a look a little closer, you'll see that that line is demonstrating how as time goes up, the velocity of this object is also changing. And if we look back at our definition for acceleration, which is a change in velocity or speed over time, this graph is showing us that this object's speed is changing over time. That blue line is representing, well, if we had a constant velocity just shooting off, well, it would just keep on going. But with most objects, especially cars, they have a constant velocity. For example, once you reach the speed limit, say the speed limit is 30 miles per hour, well, you're no longer accelerating if you're driving at 30 miles per hour. So if you take a look, once that line, that red line caps off, that's the point at which the object is no longer accelerating. It reached a cruising speed. Now I want you guys to see here that when objects are slowing down or they're decreasing their velocity, we call that a deceleration. Now, according to our definition of acceleration, which is a change in velocity over time, that deceleration is still considered an acceleration, even though we would consider it to be what's called a negative acceleration. And we're going to focus on that in class. All right, guys, the remainder of this video is going to be showing you how to mathematically calculate acceleration. If any of the previous information was confusing, rewind and watch that part again. That's the benefit of the video, guys, the power to rewind and pause. Alrighty here, guys, for the remainder of this video, I'm going to go ahead and remove my face because I want you to pay close attention to what's going on the screen. Now let's pull up our definition for acceleration once again. Acceleration is equal to a change in velocity over time. Now here's how you could mathematically show that. We could say that A is equal to a change in V, or a change in velocity, all over time. Now, if you're not familiar with high-level math, this triangle right here means that there is a change in something, or a change in velocity. It's something that you put before a variable to demonstrate there's a change in that. Now, in our class, what we're going to do is figure out a way that we can show that in an easier way. How could we demonstrate that there's a change in velocity over time? Well, think about it like this. If we know the final velocity, or the velocity at the end, or we'll call that VF, and then if we could subtract the velocity at which the object began at, or we'll call that VI, and divide that over time, that is going to show us the change in velocity. The final velocity minus the initial velocity is equal to our acceleration. So what I'm showing you here, guys, is this right here, this equation, is going to be the equation that we are going to use in our physics class. Alright, so now let's go ahead and try to apply our equation for acceleration to this graph. Once again, our equation for acceleration is A is equal to the final velocity, which we call VF, minus the initial velocity, which we call VI, all over time, divided by time. Now, I'm going to let you guys in on a little hint. Most of the time when we're doing equations in this class, VI, or the initial velocity, is going to be 0. Or another way to think about it is that we are going to use our acceleration equation as if something was starting from a velocity of 0, or otherwise known as at rest. For example, if you take a look at our graph over here, our initial velocity is 0. Now I'm going to go ahead and pay close attention to our red line, and I'm going to go ahead and ignore our blue line. And also, I don't want to calculate a constant velocity. I don't want to calculate deceleration right now. So I'm going to go ahead and cross all that out. What I do want to calculate is the acceleration from 0 all the way up to here. So we're going to go ahead and say that this point right here on my graph is VF. Now let's take a look. Let's go ahead and crunch some numbers. A is equal to VF, which according to our graph, the velocity, or the final velocity, is 8 meters per second. And what was our initial velocity? Well, that was 0, so that was easy. And now, how much time went by? Well, let's take a look. 1, 2, 3, 4 seconds went by. So 4 seconds. Now we can go ahead and crunch do our math and crunch our numbers. 8 minus 0 is 8. Divided by 4 is 2. So our acceleration rate is equal to 2 meters per second. And this is where things get tricky, guys. Per second. Another way to think about it is every second that goes by, how much velocity has been gained? How much change in velocity has happened? Well, if we take a look, after 1 second, and we put a point here, 2 meters per second has changed. Our velocity has changed by 2 meters per second. So for every second that goes by, 2 meters per second is going to increase in velocity. Once again, 2 seconds goes by. Well, now our velocity is 4 meters per second. So we added an additional 2 meters per second. 3 seconds goes by, we're at 6 meters per second. Now another way to show this, 2 meters per second is if we said A is equal to 2 meters per second squared. So usually when we talk about acceleration, we talk about it as if it was a distance over seconds or time squared. So if you see that in class, just know that 2 meters per second is the same thing as saying 2 meters per second squared. Alrighty here guys, that's going to go ahead and conclude our video on acceleration. If any of this stuff was confusing, pause, rewind, and watch that part again. Once again, that's the power of the video here, guys. Anyway, I know this type of homework assignment might be new to a lot of you, so make sure that you remember to complete the Google survey within the description of the video on YouTube. Anyway, I'll see you all in class. You all doing a great job. I'm signing off, though. Have a nice day.